Okay. Number 3. A galvanic cell has the following net reaction. B plus? Yeah. Okay, that's the net reaction. And E naught of the A couple is equal to minus 0.1 volts, and E naught of the B couple equals, what's it, minus 0.9. Okay. And so I ask you several questions. How many electrons are transferred? So A. How many electrons are transferred in the problem? And how many electrons? Yeah. Say it like Lewis Black. 2. And as you can see, this is going from 2 plus to 0. So it's going to require 2 electrons to make that happen. And this one's going from 0 to plus 1, and there's 2 of them. So it's balanced. Okay, now, so the answer to part A is 2. Part B, what is and I want to know what the potential of the cell is, and what is, how do I handle that? Which it's going to be the standard potential for the reduction of the cathode minus the reduction potential of the anode, because the anode is reversed. Okay, which is the cathode and which is going to be the anode?
Cathode's more positive.
Yeah.
A is going to be at the anode.
This is going to be the, well, this can be the cathode, because this has the more positive. This is minus 0.9. This is minus 0.1. So E cell minus 0.1 volts minus 0.9 volts equals what?
Minus 0.8.
No. Minus a minus is plus, so it's 0.8 volts.
Didn't you say the anode was the higher one, the closer?
No, since we're talking about reduction potentials, because the reduction potential is, or the voltage comes from delta G is equal to minus NFE, and when I want to have a spontaneous, okay, I'm getting too far afield, I want to have a negative delta G, right? And so, for it to be the spontaneous. So that means the higher the reduction potential, because the negative sign in that conversion, the delta G is equal minus NFE. I want the higher reduction potential. The higher the reduction potential, the more negative delta G is. Does that make sense? Since okay, delta G naught equals minus NF E naught. The more positive this is, the more negative this is. So therefore the okay. So what we're after here is, we're after what's going to be spontaneous, and ultimately what was our criteria for spontaneity? Delta G has to be less than 0. Yeah. The more negative delta G. So we want the one with a higher reduction potential has a greater driving force for that process. So when we take two half reactions, we look at one of the couples, the couple with a higher reduction potential is going to have a greater driving force for its reduction. And then so that means that the oxidized form of that couple will be reduced, will gain its electrons from the reduced form of the couple with the less, the smaller reduction potential. So the cathode's going to be the one with the highest, with the most positive reduction potential. In this case, both the reduction potentials were indeed negative, but this is less negative than that. So this became the cathode, and this and the other was we reversed it. That's why we subtracted. Okay, and so yeah, that's why. That's the cathode and that's the anode. And now part C, which we get to do some Nernst work with. Oh, this is going to be a snap. See, that's the only good thing about that first problem. After that, all of this is easy. If I take that first problem out of the test, you guys will all nail it. And you probably nail it with the first problem in there.
Oh.
Yeah, you know, here we go. Let's do part C. We needed, what information did I get? The E naught is equal to what? Was 0.8 volts? Okay. So for part C, I've got what is the cell voltage if N2 plus is equal to 10 to the minus 3. What was B plus? 10 to the minus 2. And I know on the test it said 1 times 10 to the minus 3 and 1 times 10 to the minus 2. But what do we need the 1 for? It actually just, at that point, it's confusing the issue. It's clearer if we just write the 10 to the minus 2 and 10 to the minus 3. We should be comfortable going either way. We're just losing that mantissa information and keeping it all in characteristic. So that's good. Yeah. I actually want to you get used to that kind of language. Well, I don't have that kind of language around here. I'll wash my mouth out with hydrofluoric acid. Now, so the Nernst equation we derived way back in question 0, and you guys will all be, this is a cakewalk. What is the Nernst equation at 25 degrees Celsius? E cell is equal to E naught cell minus 0.0592 volts over, and how many moles of electrons were there? It was 2 over 2 times the log of Q. And now we just have to look at what is Q. Q here is equals, now we're just substituting these values, 0.8 volts minus 0.0592 volts over 2 times the log of, and now I've got Q is equal to what?
Concentration of D over concentration of N.
The what?
Yeah, so B squared.
Yes, I must be square. And that is equal to 10 to the minus 2 squared over 10 to the minus 3. What are the rules of exponents have me do here? Yeah, I multiply, so 2 times 2 is 10 to the minus 4. 10 to the minus 4 over 10 to the minus 3 is what?
10 to the minus 1.
Log of 10 to the minus 1. That was tough. And so, and now we're going to have to probably consult a mathematics firm to find the log of 10 to the minus 1. Or, we can always call for a landline. Or what do they call it? A
Shout out?
Yeah, shout out, yes. So that is, now I did the hardest part with this problem. Okay, so the minus 1 gets pulled through. That makes this positive, so all I have to do is divide 0.0592 volts. So on your scratch paper, you go 0.0592 volts divided by 2 is 0.02 296, exactly. And that plus 8, so it's equal, this turns out to be equal to 0.8 plus 0.0296 is 0.8296 volts. That was, doesn't that seem easy after that first problem? There's a strategy for studying with that problem because it makes everything seem easy. Okay. That pretty much beats that problem to death. Go ahead and stop the camera.